Welcome to Section 7.7, Applications of Systems of Linear Equations. So hopefully by the end of this, you all will be able to set up equations for these application problems and be able to solve application problems that involve systems of linear equations. So a couple of tips just to get started before we do this. The first thing really you should be doing with these application problems is defining your variables, just figuring out what are you solving for, what are the unknown values, and I would highly recommend using variables that make sense in the context of the problem. Sometimes you guys get used to using x's and y's for everything, and then when you solve it, you have no idea what you just got. So use a variable that makes sense when you're solving your problem, so that when you solve it, you know what you got. Sometimes it gets overwhelming when you're looking at these problems. Take it one equation at a time. Often, like one sentence equals one equation. Sometimes there's compound sentences. Sometimes you do have to break apart the information and figure out what goes with what. But just take it one equation at a time. And after an equation, it's okay to take a deep breath and then keep on going. Because once you guys get the equations down, you usually do pretty well. Okay? In general, you should have as many equations as you have variables. So if you have 2 variables, you need 2 equations. If you have 3 variables, you need 3 equations. Once you have all of your equations, you get to solve them. And we've done lots of methods for solving. You guys got this, okay? And the last thing, of course, is always rereading the problem. Make sure you answered the question, you answered it completely, it makes sense what you answered. So kind of evaluating what you got and making sure that that matches with what the question is asking you to do. So let's get started. First example I've got is in a recent Major League Baseball and National Football League seasons, based on average ticket prices, 3 baseball tickets and 2 football tickets would have cost $183. So we have a little comma there, and that is one piece of information to deal with first. So let's see here. It was 3 baseball tickets and 2 football tickets. When I add those prices together, that costs $183. You notice I'm using B for baseball tickets. I'm using F for the price of football tickets, so that when I solve it, I know what I get. All right, let's breathe for a second. Now let's keep going. While it says 2 baseball tickets, so 2B, and 1 football ticket, 1F, would have cost $103. Okay? Now I have 2 equations, 2 variables. What were the average ticket prices for the tickets for the 2 sports? So I'm solving for B and I'm solving for F. When I get those 2 solved, I will be able to answer the question. Alrighty, let's go ahead and solve them then. Since they're in standard form, I kind of like using elimination, but it is up to you. You may like substitution better, and that is fine as well. If you're using elimination, what I'm going to do is I'm going to keep my first equation the same. 3b plus 2f equals 183. I'm going to take that second equation and I'm going to multiply it by -2 so that my f's are going to cancel. So that'll be -4b plus a -2f. And then 103 times -2 would be -206. All right. If I add those equations together, those f's cancel out. 3b plus -4b is -1b. And let's see here. If I do 183 minus 206, I get -23. I'll divide both sides by -1, so b equals 23. Now, of course, am I done? No, I figured out the price for a baseball ticket, though. So that's pretty good. Since I used B, I know what I just got. So the baseball tickets, their average price was $23. If I want to solve for the football tickets, I'll just use one of my equations. How about the second one? It looks nice. So I'll do 2 times my baseball ticket price, so 2 times 23, plus 1F, which is just F, equals 103. 2 times 23 is 46. And if I do 103 minus 46, I get F equals 57, which means that my football tickets had an average price of $57, which is pretty cheap for football tickets. But that answers our question. So we've figured out from our equations what the answer is and related those back to the problem. Okay? Let's do another one. Let's see, example 2. A grocer has some $4 per pound coffee and some $8 per pound coffee, and she's going to mix it to make 50 pounds of $5.60 per pound coffee. How many pounds of each should be used? So variable-wise, there's how much $4 per pound coffee that she's going to use and how much $8 per pound coffee that she's going to use. So there's kind of a difficult thing to make variables here. So I actually am just going to use X's and Y's on this, okay? So I'm just going to define those. I'm going to say that X is the amount of $4 per pound coffee. And I'm going to say that Y is the amount of $8 per pound coffee. Just so I know what those variables are and what they mean throughout the year. I'm getting some sun on my paper, so I'm going to scoot over a little bit here and see if that helps a little bit. Yep, that's a little bit better. Okay. Let's see. So now that I've defined my variables, those are the things that I'm looking for. And really what we have here is we have kind of a price information and we have pound information. So that's what I'm going to use to make my two equations. So I'm going to make a price equation and just deal with prices. Prices and costs. And then I'm going to have kind of a pounds equation, okay, but with the amounts, okay? And that's how I'm going to split up the information that I have in that paragraph. So for the price, let's see, the $4 per pound coffee, how much is it going to cost? It's going to be $4 times the amount of the $4 coffee that we use. How much is the price going to be with that $8 per pound coffee? Well, it's going to be 8 times however much of the $8 per pound coffee that we use. And then we'll add those prices together to equal our total price. And we're going to have the total price is $5.60 times the amount of coffee that we have at the end of all of this, which is 50 pounds. So that's what my price equation looks like, is it's how much money, is coming from the $4 per pound coffee, how much money is coming from that $8 per pound coffee, and then when I add those prices together, it should equal our total amount. With the pounds, we know that there's 50 pounds total, and it's only coming from these two sources. So for the pounds, I can say the amount of $4 per pound coffee and the amount of $8 per pound coffee, if I add those together, it should be 50 pounds. And so those are the two equations that I can get from the information that I have. And I kind of had to split that information apart to get there. Okay? So with this one, I honestly would probably use substitution. With an x plus y, I could subtract y from both sides and get x is 50 minus y and use substitution to solve this one. And put the 50 minus y in that first equation where there's an x. Okay? So let's go that route. So that'll be 4 times 50 minus y plus 8y. And let's go ahead and multiply that out. $5.60 times 50 is 280. Okay? Then I can also go ahead and distribute so that I can solve for y. 4 times 50 is 200. 4 times y is 4y. I still have a plus 8y and it equals 280. Let's go ahead and subtract 200 from both sides. And we can go ahead and combine like terms. Negative 4y plus 8y is a positive 4y. 280 minus 200 would be 80, and then if I divide both sides by 4, I'm going to get 20. So what that tells me, going back up, and This is why if you use something else for your variables, it's good to define them at the beginning. Now I know that my y was the amount of $8 per pound coffee that I'm going to use. So I know that I'm going to have 20 pounds of the $8 per pound coffee. So I'll put that over to the side. So the $8 per pound coffee, we're going to use 20 pounds. Okay. It does ask how many of each should be used. So we still need to solve for x as well. But x isn't too bad. X is equal to 50 minus y. So I'm going to do 50 minus 20, since 20 is y, and get x is 30. So the amount of $4 per pound coffee that the grocer is going to be using is going to be 30 pounds to get that blend that she wants. Okay? And there's my answers on